First, we measured the length of 100 miles with our ruler in inches, which was 1/2 of an inch. This meant that 1/2 is to 100, which we can now use in our proportions. We created 4 triangles in the shape of Texas. The first triangle, the one closest to the left, is an isosceles triangle. To find the area, we created a proportional relationship. We set the base of a triangle, in this case 1 over x, to equal 0.5 over 100. We then did this for height, so in this case 0.5 over 100 equals 0.7 over x. The height was 140 miles and the base was 200. We then plugged this into our area equation for a triangle, 1/2 base times height, and got 14,000 meters squared. We repeated this for the 3 other triangles, and the sum of the area of all 4 triangles is 83,900 meters squared.
To find the area of a rectangle, I had to set up the proportion 1/2 over 100 equals 0.9 over x, where 0.9 is the base of the triangle in inches. After I cross-multiplied and solved for x, I found out that the base of the triangle is 180 in miles. Next, I did the same thing with the height and found the height of the rectangle in miles to be 175. Finally, I plugged these numbers into the area equals base times height formula and found the area of the rectangle to be 63,000 miles squared.
To find the area of Texas, we used a kite as one of our shapes. The equation for the area of a kite is diagonal 1 times diagonal 2 divided by 2. To find the area, we had to convert the measurements we had in inches to the scale proportion we had. To find the area of the kite, we need to convert the 2 diagonal measurements. To do this, you set a proportion, which is diagonal over x equals 0.5 over 100. This proportion allows you to convert measurements to get the real area. After you find the 2 new measurements from diagonal 1 and diagonal 2, you multiply the 2, which gives you the area of the kite shape in Texas, which equals to 48,000 miles squared.
Our final area was 302,975 miles squared.